I'm just making this video to show you guys what it looks like in terms of system resources when using DaVinci Resolve to output three different file types. Whether you're going to output H.265, these are all in 4K, you're going to output H.264, or you're just going to output your traditional MPEG, an MPEG4 video. So I've already got this 3.5 minute file in 4K in the render queue, and I'll show in system resources what it takes because they're different. They're actually relatively different. Right now I am using streaming software, so that's taking up a certain amount of GPU activity here from Intel Arc, but it should still demonstrate nonetheless kind of what the options are. So this is our baseline because the streaming software is on and using GPU resources. You've got about between 18 and 20% of the GPU being used, and it's mostly in the video decode segment of what the GPU can do. CPU, it's running about 6%, and this CPU right here is 16 core, 32 thread, Ryzen 3950X. Okay, so I'll turn on the render. First with H.265. You can see that with the H.265, it's running at roughly at 100% GPU. So you can see here on the breakdown screen that there is both the regular old video decode that's being used, right? Video decode 1. But there's also, which is a smaller percentage of everything, but in total video decode, it's using 100% of the GPU's processor. If you look at CPU, H.265, it's using a little bit more CPU, but the baseline is that the CPU isn't really being used as much as it was previously. We're at 66%, 68% of the render being completed. And then we'll see that this will go back to the baselines that we had before once it's complete. With the render complete, we can see that we're going back to these baselines where GPU utilization is mostly just from streaming. Now we'll try H.264. And in H.264, it is much more processor intensive. We can see here that 16 core processor is actually getting used quite a bit. GPU usage is down quite a bit. Doesn't mean it's not using GPU, but it's using a little less GPU. It's using some copy operations from the GPU, but not much in terms of decode or overall GPU utilization. We're at 70% of this render operation at 4K, and we'll see it drop to baseline once it's done with the render. Now that we're back down to baseline, you can see that there's no copy operations. GPU utilizations and processor utilization in the 6% range, 7% range is just from having the streaming program running. Traditional MPEG4, let's see what that render operation looks like. MPEG4 is happening very quickly. You can see that it's a mix. With MPEG4, based on the codec, you've got relatively decent processor utilization, about 40%. GPU utilization's around 60%. On top of the baseline, so it's about 40%. So when you're doing an MPEG4 render, it's going to be about half and half between what it's calling of the CPU and what it's calling out of from the GPU. So in summary, just to compare, H.265 took 1 minute and 21 seconds. H.264 took 53 seconds, and an MPEG4 took 26 seconds. So the harder it is on hardware, obviously, the longer it's going to take. We're going from newest to oldest file format, and it looks like the newest file formats definitely work a lot more on the GPU than they do on the CPU. But the MPEG standard, which is the oldest, is what's going to take less GPU compute. Actually, let's take a look at the file sizes here. So if we look at the three different file sizes here, Starting with the H.265, it's a 168 megabyte file. The H.264 is 279 megabyte file, and the MPEG is a 335 megabyte file. So the reason why the codecs are getting newer is to try to minimize the file sizes that are being created so that it uses less bandwidth on the internet and produces a higher quality. But what it also means is that it requires a much higher quality or more expensive hardware, newer hardware, to produce these file formats to be able to do the compression for them. So an MPEG's going to produce a much bigger file, and it's going to take forever to upload to YouTube or whatever it might be compared to, say, like an H.265, but it is going to be much better in terms of bandwidth use overall on the internet. Thanks for taking a look, and I hope this little video is helping somebody out. See you next time.